Friends, how are you? Hope you all will be fine at home. Okay, so let's start today's video lecture. Today we will discuss about polynomials. This is our second chapter, polynomials. So first of all we should know what is a polynomial. So beta, polynomial is an algebraic expression. What is polynomial? Polynomial is an algebraic expression consisting of variables and coefficients that involves only the operations of addition, subtraction, multiplication and non-negative integer exponent of variable. So there are some points which you have to keep in your mind. What is a polynomial? So first of all, a polynomial is an algebraic expression. Understood? And what is an algebraic expression? You know, we have already studied in previous class in grade 8 what is an algebraic expression. So what is a polynomial? First of all, it is an algebraic expression that consists of variables and the coefficients that involves the operations of addition, subtraction and multiplication. And the exponent of the variable should be a non-negative integer. These are the points which you have to keep in your mind. For example, 2x square plus 5x minus 7. Because this is an algebraic expression which consists of variables and coefficients. You know the variables. Here x is variable which consists of variable and the coefficients. Coefficient means constant term, means numerals 2, 5 and 7. So it is an algebraic expression consisting of variable and the coefficients that involves the operation of addition, subtraction and multiplication. So see, addition is here, subtraction is here and the multiplication 5 and x. There is no sign in between them. That means there is multiplication between 5 and x. So multiplication is also there. Understood? So first condition is polynomial is an algebraic expression. So this is an algebraic expression. Second condition, that consists of variables and the coefficients. So variables and coefficients are here. Third condition, that involves the operation of addition, subtraction and multiplication. So addition, subtraction and multiplication all are here. And the last and the most important point, the power, the exponent of the variable should be a non-negative integer. Means the power of variable should not be fractional. The power of variable should not be fractional. Means power should not be 1 by 2, 1 by 3, 2 by 5 like this. Second thing, it should not be negative because here it is written and non-negative integer exponents, means exponent should be non-negative. Non-negative means power should not be negative. Y to the power minus 1, x to the power minus 2, x to the power minus 5. So 2 or 3 things should be you have to keep in your mind. Power should not be negative. It should be an algebraic expression and the which consists of variables and the numerals. Understood? So here the power of the variables are 2 and if nothing in the power there is nothing, so it is understood there is always 1. So here the power is 1 and here the power is 2. So 2 and 1 both are non-negative integer. That's why this is a polynomial. Understood? Again I am explaining the definition. A polynomial, first thing, polynomial is an algebraic expression. Second thing, that consists of variables and the coefficient. Third condition, that involves the operation addition, subtraction and multiplication. And the last and the most important point, the power of the variable should be a non-negative integer, means power should not be fractional or power should not be negative. Hope it is clear to everyone. Okay, now we will discuss how we have to identify this is a polynomial or not. So I am taking some examples here. 3x to the power 5 plus 7 x square plus 9 under root x minus 7. Second example I am taking 2x cube plus 7 upon x. Third example I am taking 5x to the power minus 3 plus 7x square plus 4. Next example I am taking 2x square plus 5x cube minus 50. So out of these four examples, we have to identify which is a polynomial or which is not a polynomial. So the very first condition, it should be an algebraic expression. So here all these four examples are of algebraic expressions. First condition is satisfied. Second, that consists of variables and the coefficients. All these examples consist variables and coefficients. Clear? Now the most important property is the power of the variable should be a non-negative integer. Power should not be negative or fractional. So see here, power of x is 5. This is non-negative integer. Power of x 2. This is also non-negative integer. But here under root x, we know that under root x means square root x can be written as x to the power 1 by 2. Square root symbol denoted as the half power. So under root x can be written as x to the power 1 by 2. So 1 by 2 is not an integer, it is fractional. So if the power of variable is fractional, that means this algebraic expression is not a polynomial. Clear? Second example. This is an algebraic expression. Now see, the power should be a non-negative integer. Here the power of x is 3. This is non-negative integer. But here 7 upon x. So we know that if x is in denominator or we want to write in numerator, so the power will be negative. So it is x to the power minus 1. So 7 upon x. So here x to the power is minus 1. Or condition is the power should be a non-negative integer. But here the power of x is minus 1. Minus 1 is an negative integer. So again, this is not a polynomial. Clear? Next, 5x to the power minus 3, 7x square plus 4. Here the power of first x is minus 3. Power of variable should not be negative. Here the power is minus 3. That means this is also not a polynomial. Here 2x square plus 5x cube minus 15. The power of x is what? 2. 2 is a non-negative integer. 3. It is also a non-negative integer. That means this algebraic expression is a polynomial. Understood? Hope you can identify which is a polynomial or which is not a polynomial. Understood? So now the very first question of exercise 3.1 is same as this. Some algebraic expressions are given there and we have to identify out of those algebraic expressions which is a polynomial in one variable. What is a polynomial? Which is a polynomial in one variable. So I am taking some examples here so that you can identify which is a polynomial in one variable. First example I am taking 2x to the power 3 plus 7x square y minus 9. Second example 5y to the power 7 plus 6y to the power 5 minus 4y plus 5. Third example 8x square plus 9 upon x minus 17. Fourth example is 4x cube plus 5x square plus 4 under root x plus 7. These are four algebraic expressions and we have to identify out of these which is a polynomial in one variable. Which is the polynomial in one variable. Clear? So see the very first example. For being a polynomial, it should be an algebraic expression. So all these four examples are algebraic expression. The main condition, the power should be non-negative integer. Means power should not be negative or power should not be fraction. So here, the power of x is 3, the power of x is 2 and the power of y is 1. So 1, 2 and 3 all are non-negative integer here. So this is a polynomial. But question is, which is a polynomial in one variable? Means only one variable should be there. How many variables are here? X and y. So there are two variables. So you have to write, no, it is not a polynomial in one variable. Why it is not a polynomial in one variable? Because two variables are here, x and y. Otherwise it is a polynomial. This is a polynomial in two variables. But question is asking which is a polynomial in one variable. So it is not a polynomial in one variable because two variables are here. Understood? Second one. 5y to the power 7 plus 6y to the power 5 minus 4y plus 5. Here only one variable is present, that is y. Clear? So this is one variable. Now we have to check this is a polynomial or not. So here the power of this y is 7, 5 and 1. And 1, 5 and 7 all are non-negative integers. That means this is a polynomial in one variable. So yes, it is a polynomial in one variable. Clear? Third one, only one variable is present, that is x, but it is not a polynomial. Why? Because here the power of x is 2, but this is 9 upon x. If x is in denominator, so its power will be negative. I explained you. So 9 upon x is 9 into x to the power minus 1. So here x to the power is minus 1. So, but the condition is power should not be negative. That means it is not a polynomial. Here one variable is there, only x is present, no other variable is there. So this is one variable. But the power of x is 3 and 2. Both are non-negative integer. But this is under root x. I told you, whenever under root x will be there, then x, under root x can be written as x to the power 1 by 2. So here the power of x is how much? 1 by 2. That is fractional. So it is also not a polynomial. Understood? Hope this concept is clear. Now you can identify which is a polynomial in one variable or not a polynomial in one variable. Clear? Okay. Now I am explaining the next topic, that is terms of a polynomial. What? Terms of a polynomial. So our next topic is terms of polynomial. For example, 5x to the power 4 plus 7x cube minus x plus 15. This is a polynomial. If I am asking how many terms are here, so beta 5x to the power 4 is one term, 7x cube next term, x is another term and 15 is another term. The sign of plus and minus separate the terms. Understood? The sign of plus or minus in a polynomial separates the term. So here this plus sign is there. So one term is just before the plus sign or another term is just after the plus sign. Now minus is here. So one term is before the minus and another term is after minus. So how many terms are there? This is first term, second term, third term and fourth term. Clear? If somebody asks what is its second term, So your answer will be 7x cube. This is the second term of this polynomial. What is the fourth term of this polynomial? So 15 is the fourth term of this polynomial. Hope it is clear. Okay, take one more example. Ax square plus bx plus c. How many terms are here? Simple. First term is ax square. This is before the plus sign. And after plus there is bx. And after this plus there is c. So how many terms are there? 1, 2 and 3. So there are 3 terms in this polynomial. First term is ax square. Second term is bx. And third term is c. Hope it is clear to everyone. Okay, one more example. 7x square. How many terms are present here? Because there is no plus sign or no minus sign. If there is no plus or minus sign, that means there is only one term. That is 7x square. So here is only one term. Hope it is clear. Okay. Now, our next topic is coefficient of the terms. Coefficient of terms. For example, suppose that if this polynomial is given 5x to the power 4 plus 7x cube minus x or plus 15. Somebody asks you, what is the coefficient of x to the power 4? What is the coefficient of x to the power 4? So beta, whatever is in multiplication of x to the power 4 will be the coefficient of x to the power 4. Clear? So what is in the multiplication of x to the power 4? X to the power 4 is multiplied by 5. So 5 is known as coefficient of x to the power 4. Clear? What is the coefficient of x cube here? So x cube is present here. So it is multiplied by 7. So this is the coefficient of x to the power 3. If somebody asks you what is the coefficient of x, but x is this. But there is nothing here which is in multiplication of x. If nothing is there, then we can put 1 or not. Because 1 into x gives you x. So the coefficient of x will be minus 1. This is coefficient of x. Clear? We have if negative sign is there, then we have to take minus also. So what is the coefficient of x here? That is minus 1. Okay, now tell me, what is the coefficient of x square in this polynomial? What is the coefficient of x square in this polynomial? Yes, tell. Yes, absolutely correct. A is the coefficient of x square because a is in a multiplication of x square. So this is coefficient of x square. What is the coefficient of x? Coefficient of x. Yes, b is the coefficient of x. So hope it is clear to everyone how can we identify which is a polynomial, or how can we identify the number of terms of the polynomial, or how can we find out the coefficient of any variable. Clear? Okay. So our next topic is degree of a polynomial. What I am saying? Next topic is degree of polynomial. What is the degree of polynomial? But a degree of a polynomial is the highest power of the variable in that polynomial. The highest power of the variable in that polynomial is known as degree of the polynomial. See. Now we will discuss about degree of polynomial. Next topic is degree of polynomial. The highest power of variable in a polynomial is known as degree of polynomial. For example, 2x square plus 3x to the power 5 plus 7x minus 9x to the power 6. This polynomial is given and we have to find what is the degree of this polynomial. So beta, the highest power of variable is known as the degree. So what is variable here? Variable is x, and x. So variable is x. Now the highest power of x. The power of x are 2, 5, 1 and 6. So out of 1, 2, 5 and 6, what is the highest power? Highest power is 6. So degree of this polynomial will be 6. Clear? One more example. 3x square plus 5x cube plus 7x minus 19. What will be the degree of this polynomial? The highest power of variable. So what is variable? Variable is x. So what is highest power? Power is 2, 3 and 1. So out of 1, 2 and 3, what is highest? Highest is 3. So this will be the degree of this polynomial. Degree of this polynomial is 3. Is that clear? Good. Okay students, now we will discuss types of polynomials. Types of polynomials. So on the basis of number of terms, we can classify the polynomial. The first type of polynomial is monomial. First type of polynomial is monomials. A polynomial having one term. A polynomial having one term is known as monomial. Means a polynomial in which only one term is present is known as monomial. For example, 7x square. There is no plus or minus sign. That means there is only one term. That is 7x square. So it is an example of monomial. M. This is also a monomial because only one term is present here. 5y. This is also monomial because only one term is present. So these are the examples of monomial. Clear? Second type is binomials. Second type is binomials. Bi stand for 2. A polynomial of 2 terms. A polynomial of 2 terms is known as binomial. Means a polynomial in which 2 terms are present. For example, a plus b. So 2 terms are here. One term is before the plus sign or one term is after plus sign. Next example, 7x square plus x. Again there are 2 terms. Next term, x minus 5. Again 2 terms are there. That means these are the example of binomials. Third type is trinomials. What is third type? Trinomials. Tri means 3. A polynomial of 3 terms. A polynomial of 3 terms is known as trinomial. Means a polynomial in which 3 terms are present. For example, 7x square plus x minus 5. There are 3 terms. First term is 7x square, second term is x or third term is 5. Clear? Next, m cube plus m square plus m. There are 3 terms, 1, 2 and 3. This is also an example of trinomials. Next example, 2 upon 3 p square minus 5 upon 6 p minus 1 upon 7. Again 3 terms are here. First term is 2 upon 3p square. Second term is 5 upon 6p. Or third term is 1 upon 7. This is also an example of trinomial. So, on the basis of number of terms, there are 3 types of polynomials. One is monomial. Monomial is a polynomial of 1 term. Second type is binomial. A polynomial of 2 terms is known as binomial. And the third type is trinomial. A polynomial of 3 terms is known as trinomial. Understood? Now, on the basis of degree of the polynomial, again polynomial are of 3 types. Clear? On the basis of degree of polynomial. These types are on the basis of number of terms. Clear? So, on the basis of degree of the polynomial, polynomials are of 2 types. Sorry, 3 types. First type is linear polynomial. Linear polynomial is a polynomial of degree 1. Means a polynomial whose degree is 1 is known as linear polynomial. A polynomial whose degree is 1. And what is the degree? Degree is the highest power of the variable. Means the highest power of the variable is 1. Then the polynomial is known as linear polynomial. For example, x plus 5. Here the variable is x and its power is 1 and it is the highest power, so it is a linear polynomial. Next, p minus 7. Here the variable is p and its degree is 1, so it is an example of linear polynomial. Clear? Second type is quadratic polynomial. A polynomial of degree 2 means a polynomial whose degree is 2 is known as quadratic polynomial. So a polynomial of degree 2. For example, degree 2 means the highest power of the variable should be 2. That is m square plus m minus 5. Here the variable is m and the highest power is 2. So its degree is 2. That's why it is an example of quadratic polynomial. Next, 3y square minus 5y minus 17. Again, here variable is y and its highest power is 2. So its degree is 2, or if degree is 2, that means it is a quadratic polynomial. So these are the examples of quadratic polynomial. Third type is cubic polynomial. Means a polynomial of degree 3. A polynomial of degree 3 is known as cubic polynomial. Means a polynomial in which the highest power of the variable is 3 is known as cubic polynomial. For example, 7z to the power 3 plus 5z square minus z plus 5. Here the variable is z and its highest power is 3. So its degree will be 3, or if degree is 3, that means it is an example of cubic polynomial. Or a cube minus 81. Here the variable is a and its highest power is 3. So its degree is 3, or if degree is 3, then this is an example of cubic polynomial. Clear? So now I am going to bind up this video. After this video, I will provide you one assignment based on exercise 2.1. where all the questions are based on the topics which I have already discussed today. Clear? So you have to try those sums at home. We will meet again in the very next video. Till that time, stay at home, be safe. Thank you.